Alright, let's look at the second video on rational exponents. So let's look at some properties. Here we have a to the m times a to the n equals a to the m plus n. So if we're multiplying and we have like bases, we add the exponents. And I have some more videos on simplifying exponents, and it's similar to this video. The only difference is in this video the exponents are fractions, and in the other video they're integers. So you can watch the video on simplifying integer exponents to get some more help on the properties of how to use the properties. Alright, so let's look at this. We have 64 to the 1/6 times 64 to the 1/2. So you can see that our bases are the same. So that means we're going to use this property. We're multiplying, so we add the exponents. So this is equal to 64 to the 1/6 plus 1/2. Okay. And then when we add the exponents, we get 64, and then 1/6 plus 1/2 is 2/3. Now let's simplify it, and we're going to simplify it just like we did in the first video. So this is going to be the cube root of 64, and that's squared. So that's going to be the cube root of 64 is 4 squared, which equals 16. And there's our answer. Alright, let's take a look at this one. A to the m over a to the n. We're dividing. The bases are the same, so we subtract the exponents. So let's look at this one. We have 9 to the 3/4 minus 1/4. So this is equal to 9, and that's going to be 2/4, which reduces to 1/2. And so that gives us the square root of 9 equals 3. And like I said, you can watch the first video on rational exponents to see how to convert from exponential to radical form and simplify it. I'll show you how to do it in that one. Alright, what about this one? I have a to the m raised to the n. So this right here means we multiply the two, the m and the n. So this would be what? 2 to the 1/6 times 1/2. So we multiply, we get 2 to the 1/12. And we can leave it like this, or we can convert this to radical form. If we convert it to radical form, this would be the 12th root of 2. And we could leave it like this. Or we can leave it like this. Now let's look at this one. We have a times b to the n. So that's a to the n times b to the n. So what we do is we raise each term inside the parentheses to this exponent outside. So let's look at this problem. Now in these problems, we're going to assume that all the variables represent positive real numbers. Okay, all the variables are positive. So this is equal to x to the 12th raised to the 1/4, y to the 6th raised to the 1/4. Okay. So here we get x to the 12 times 1/4 times y to the 6th times 1/4. So 12 times 1/4, that's going to be x cubed. 6 times 1/4, that's going to be y to the 3/2. And this is our answer. Now, let's take a look at one more. We have a over b to the n equals a to the n over b to the n. So we raise each term inside the parentheses to this exponent outside. So this is going to give me y to the 18th raised to the 1/3 over 27 to the 1/3. So this is y to the 18 times 1/3 over, and then 27 to the 1/3. 27 to the 1/3 is the same thing as the cube root of 27, which equals 3. Okay, this is 27 to the 1/3. We convert it to radical form, just like we did in the first part, in the first video of rational exponents. So this is 3 down here. So 18 times 1/3, that's y to the 6th over 3. And this is our answer. And that's all of rational exponents.